Hello everybody. Alright, so here we're going to try to solve some logarithmic equations. And to solve these equations you usually use one of these two important ideas. The first one is if you have a logarithm on one side and some number on the other, the easiest way to solve that is usually to put it into the exponential. So here the base stays the same, the output turns into the exponent, and the input turns into the output. So that's taking it and using the idea of inverses. Again, that's when you have one logarithm and a number or a variable over here. If you have a logarithm on both sides, then what you want to do is, as long as they're the same base, the inputs have got to be equal. Or sometimes you do the opposite, where if you have two things that are equal and positive, they've got to be positive, then you can take the logarithm on both sides, as long as you do the same base. Remember, these have to be positive because of the input. The input must be positive. Otherwise, you're going to get domain errors for the logarithms. So we're going to take a look at three examples on how to solve these. Here's our first one. So appropriate directions, said the word solve. I have an equal sign. I have stuff on both sides. I have an equation. So what kind of equation do we have? We have a logarithmic equation. Equation because an equal sign both sides. Log equation because you see logarithms. And here I see two logarithms and I don't see any constants. So I kind of want to use that first tool. And only thing I need to do is I need to bring this 2 up first. So I can rewrite this as log base 5 of x squared equals log base 5 of 9. Keeping my equal sign in the same spot, working vertically down because we got an equation. Okay, and now I can use that property which says here I have log base 5 and log base 5, so the inputs have got to be equal. Okay, and what kind of equation do we have here? Got ourselves a quadratic, right? I got x squared. I'm going to get this equal to 0 and I'm going to factor. Although I know you can do square root method here too, but whenever I do the square root method, I can sometimes forget that plus or minus. So here I get x equals minus 3 and x equals 3. And remember, you have a log equation, so you have to check these answers. It's very important. So let's see, if I put in a minus 3, can I take log base 5 of minus 3? No, because we have positive numbers only in the logarithm. What about 3? Can you put a 3 into here? Sure. Your one answer works. We rule this one out because we cannot have negatives in the inputs of logarithms. Okay, that's example 1. Let's take a look at another. Okay, clear directions to solve, and I've got another logarithmic equation. So this time I see I have two logarithms over here. They're both base 5. It's convenient, and I have a number. Alright, so I know that I'm going to solve this in the following way, and you're going to figure this out once you do enough problems. But here, what I'm going to do is I'm going to put these two together because they're the same base. So I can rewrite this as log base 5 of addition of same base logarithms turns into multiplication of their inputs. Why would you want to do this? Because now I have a logarithm equals a number. And now I can use that key idea number 1. So I'm going to put this into the exponential. Here I have base 5, its exponent is the old output, and this equals the input. This is usually what I do whenever I see a logarithm and I see a constant or a variable or a non-logarithm on one side. I put it into the exponential, and I'm going to solve that. So here we have another quadratic. And remember, quadratics have to be equal to 0. So I take 5 to the first and make this 5. Here I'm going to FOIL this out. So I get x squared plus 2x plus 6x plus 12 combined with those like terms. So x squared plus 8x plus 12. Give myself some more room here. Move the 5 over. 0 equals x squared plus 8x plus 7. Factor. So x plus 7, x plus 1. And here I get possible answers of x equals minus 7, and x equals minus 1. The question is, how many answers do we have? So let's go back and let's look at the original equation, which is right there. So here I know students will get a little bit confused. Answers can be negative. They just can't cause the input to be negative. So if I try to plug a minus 7 in, minus 7 plus 6 is minus 1. And you can't put in a negative number into a logarithm. This guy is eliminated. When I try this minus 1 plus 6 is 5. That's okay. It's a positive number. and minus 1 plus 2 is 1, and that's okay, it's a positive number. So I'm pretty confident this is actually going to work. But I'm going to go through and do the rigorous check here. So let's check this and see. So I'm going to plug this into original. So we have log base 5 of minus 1 plus 6 plus log base 5 of minus 1 plus 2. And I'm wondering if this is going to equal the number 1. So this is log base 5 of minus 1 plus 6 is 5, plus log base 5 of minus 1 plus 2 is 1. Log base 5 of 5, and I want to do this just so we get some practice with those properties from the previous video. So log base 5 of 5 is what? Well, 5 to what power gives you 5? That's going to be a 1. Plus log base 5 of 1 is 0, and 1 plus 0 equals 1. So we got it. Okay, let's take a look at one more. Okay, here's our last one. So solve. I have 5 to the x equals 3 to the 3x plus 2. So here I have an exponential equation. Usually what we try to do here is we try to get the same base. So we try to get them to be the same base and the exponents are equal. But here we're going to have trouble because it's very hard to get 5 and 3 to be the same base. So what I'm going to do is I'm going to take a logarithm on both sides. But there's something to think about here, which is are both of these sides positive always? And the answer here is yes. This is an exponential function with a base bigger than 1. You should know the properties of this. And you should know one thing about it is the range of this function is open 0 to infinity. This is only going to spit out positive numbers. And similarly, this side is only going to spit out positive numbers as well. There is some thought to be put in there. But what I'm going to do is I'm going to take ln of both sides. You can technically do any logarithm you like, but ln's nice because it lets you plug it in the calculator and check at the end if you need to do that. So here I'm going to take ln of 5 to the x equals ln of 3 to the 3x plus 2. And I keep this equal sign, I keep working vertically down. Now I'm going to bring the exponents down. That is one super nice property of logarithms. The whole point is it lets you bring these guys out from being an exponent, lets you solve it. So the x comes out, I have x times ln of 5 equals, and here I'm going to be super careful. This whole thing is the exponent. So I'm going to wrap this guy out in parentheses. So it's 2 times ln of 3. What you need to not get freaked out about here is that these ln's, this ln of 3, there's no variable here. This is just a number, like 8 or 7 or 12. Okay, it's not, students get so confused that they think this is a variable. It's not, it's just a number. So now I'm going to take that number and I'm going to do my favorite thing in the world. I'm going to distribute. So everybody gets a piece of this ln3. Myself a little bit more room here. So I have x ln5 equals 3x ln3 plus 2 ln3. Now I'm going to get x terms on one side. So I'll move this term over there, minus 3x ln3 both sides. And you'll see why we're doing this in a second. So over here I have x ln5 minus 3x ln3 equals 2 ln3. The reason why you collect x terms on one side is it lets you factor. So I'm going to factor out that x. So it's x parenthesis ln5 minus 3 ln3 equals 2 ln3. Hope we can get a little bit more space here. Okay, and now finally we're going to divide. Take both sides and divide by ln5 minus 3 ln3. And we get our solution. These guys cancel on this side. We get x is 2 ln3 over ln5, a little more space, minus 3 ln3. Okay, it's not maybe the nicest answer in the world, but it's an answer, and this is just a number. Okay, this is a number, there's no variables in here, just some kind of messy looking number. Okay, that'll do it for this section.